Yes. We fucking back at it again. Ha ha! What's up? You're live. Manage stream. All right, fellas. Tea time. Oh. So today we gotta do a couple things. Today we gotta do a couple things. The main one. So we left off last time. I'm just getting into this shit. There's no point in waiting around. So did a lot of thinking about Jesus, about how the different components are going to live on the board, where they're going to be relative to each other. But one of the key pieces yet that we haven't really prototyped is this area of the circuit. This is the buck converter that lets us go from the 12 volts that are going to be powering the whole thing. Need to get my mix right. Let me get my mix right in the mix. So AP63357. Let's actually get into his data sheet. So this is a buck converter that I have some experience using. It's like the size of a grain of rice. It's really small. Actually, SparkFun sells. Whoops. SparkFun sells one of these on a PCB, which I've used before. Oh, SparkFun's got a new website, dude. Looking nice. Is it looking nice? It's blue. I'm so nostalgic for SparkFun. Anyways, so this is how I got into this part, by modifying one of these. And I have a bunch of these in stock. I've actually designed a PCB around these before. Let me see. Let me pull that up actually. For another project. Projects, Tesla cooler, PWM fan driver. This is it. Is it gonna let me open both at once? It is. So yeah, this is that board. So I don't have a model for the part, but the idea is that it's a buck converter. So I have one of these boards here And I want to make sure, I wanted to see if, what is the test point that I care about? I wanted to see if this can drive the BeagleBone, basically. Yeah, TP3 is the one I care about. Actually, no, TP1. Okay. So I think we should do that first. Because if that doesn't work, then we're gonna have to rethink this block. So we're over here with it. Let me go like this. Check 1 2. Check 1 2. Can you hear me? Can you hear me? Can you hear me? Check. Got the scope. This is the PCB in question. Yeah. Not much to it. This board is mostly just a connectorized output. It is a PWM input, so we're going to be using the square wave generator to set it, and then yeah, it's like it's supposed, instead of it being a constant DC voltage, it's a variable DC voltage output. So we're going to try to power the BeagleBone with it, I think, is the plan. But first, I got lots of cameras today. All right, so let's get into this. So we have, what do we have? I'm gonna use a separate breadboard for this couple of experiments. Why risk frying the BeagleBone at this point? Until the end, then we're gonna risk frying the BeagleBone. Just got, this one is doing nothing. It goes over here. Let's get this off. This guy will go here. I guess actually we don't need the scope for right now. Check. So you can move. You can see all this. Yeah, that's right. All right. So you can get all of this stuff over here. Just focus on this little number. All right. So first things first, we got to power this. So I got these two B and C leads. So these will go into the power supply. So ground. The in. Get some jumpers. So you have to short, there's an enable pin here. You have to short the enable pin to ground, or to excuse me, to VN. Okay. So now we should hook up the scope. Actually, no, we should get the function generator in here. Got a million BNCs. So we'll go out of the function generator with this, which you can't see, which is a little bit annoying, but that's okay. You will be able to see the scope, which is the critical part. So let's make so we got to get the input from these input from the function generator, which I'll use with this connector. We just have to make sure that that is properly grounded. So like this. I'm gonna get this guy. Which is just, yeah, there'll be enough length there. I'm gonna use these two. These are like little bananas with the screw turn with like a screw inside. Banana jacks. Okay, so first we're just gonna ground the function generator right to the power supply out there. And then we're going to don't exactly have the greatest setup, but who does? Take the PWM input and put it there. Okay, so let's first look at that. So the input we can do off of this test point here. Okay. Nice. Okay, so I'm gonna switch to. Now we can see the scope. So I'm feeding in a 20 kilohertz square wave. So if I, yeah, nice. Okay. So that's me turning the scope off. And so now what we'll do is we're gonna change the duty cycle. So I'm gonna go to duty, frequency, first, invert, frequency unit, trace, phase, duty. So now we're gonna try decrease, nice. Okay. So what we can do, so this is the input, right? So the volts per division here is 1. The amplitude, what is the amplitude? Amplitude is 3.3 volts, which is what it's designed to be used around. Okay, so now what we can do is we can turn on the DC to DC converter. So what I'll do is get another probe. You can put that on channel 2. So what we're gonna do is essentially try to get this thing to produce 5 volts by manually setting the duty cycle and then looking at the output voltage. So we want this to be the same thing, 1 volt per division. I'm gonna center this. I'm gonna center this as well. So power supply's on. So let's grab this. Let us look at the output. Out is here. We have the ground reference. Boom. Don't really know why. So let's add some stats. We can do measure. Source is V channel 2. Counter. So we can do on this menu, we can go to I think we should be able to get to Vmax. So now we have Vmax down there. So I am just going to plug this in. Whoa. Vmax is 5 volts. That makes a lot of sense because we have a duty cycle. So let me bring the duty cycle down to 50. Now duty cycle is 50 on the input. Maybe it's the fact that, so this is not what I expected to see. What I expected to see here was Maybe it's just because the voltage is too low. I think it also might be because there's no load on the output. So I have a DC load that I'm going to use. So I'm going to load the output. So that's these two wires. So current mode, we're gonna have this draw 0.1 amps. So we gotta move this output. So now the output's over here. Okay, so we have we're gonna move the DC load. And granted, I'm actually only looking at the output of the filter. I'm not really looking at, there we go. Okay, so now what do we see? Output voltage goes to 0. Okay, I'm seeing that. I am not at all seeing what I expected. So we're going to switch to 2 volts per division. We are going to look at the power good pin now, because I'm having a hard time understanding what's happening. And we're going to see if it is saying the power is good or not. I don't really know how the PG pin works. I've never really messed with it that much. But there's no time like the present. Okay. So this is, I believe, okay, come on, bro. Okay, so now channel 3 is on power good, which is off. Maybe it's active low, because I'm like flipping it. I'm like changing the input voltage a lot. I think it's active low. All right, so I'm going to set the input voltage to 12 volts. And then we're going to start messing with the duty cycle. Oh, you know what? There we go. So the faster you clock the input, so basically with this circuit, the faster you clock the input, the lower the voltage goes. So let me do duty cycle. I don't know why this is like rounded crazy. So now duty cycle is 90%. Yeah, so the output is 6 volts. Can I get it to go lower? Okay, this is kind of all over the place. Let me get a multimeter in here. But I mean, sorry, you can't see the circuit. Let me get a multimeter in here, because the output is pretty fucking noisy. That's probably just a bad circuit design. So output is okay. Yeah, so it's moving around pretty considerably. So what I'll do is with this hand, I will try to oh, I switched. Oh, I did it the wrong way. Oh, you know what? The freaking ground came out. I need longer wires. BRB. I got the better tool for the job now. So DC load came unplugged. So let's fix that. Okay, maybe it wasn't enough current. So now I just switched it. I'm going to do current 0.5 amps. Yeah, okay. Fucking goddamn. So it was the low current. So look how much steadier that is now. So do we even need to do this anymore? I'm not going to. All right, so let's dial this up to 5 volts. Okay, so we got 5.04. We got 5 on the DC load. We got .8 on the scope. I'm going to measure this. .2. Ooh. That was my finger touching it. So I am going to trust, man. The meter and the scope agree, so I am going to go off of that. I'm going to turn this down a little bit more. .91% input duty cycle. 4.8. Yeah. So I gotta do halves of percents. All right. All right. 5.09, 5.0. So let's see if this changes with the load characteristic at all. So I'm going to do draw more current. 1 amp. Nice. Okay, so it didn't move at all. Let me get the little camera, because that's how much it said it was going to be drawing. I got the thermal camera now. You can see my lights. So let's see how this looks. Oh yeah, it's totally fine. The chip is definitely the hotspot on the board, but it's definitely fine. Okay, so now we have this all wired up. I am going to do a little bit of cleaning. And then we're going to try plugging in the BeagleBone. And just like everybody else in my life, my nose is stuffed up. So sorry about that. Apologies. It's that time of year, man. Indoor time of year. Everybody getting sick. All right, so BeagleBone is here. I like neurotically clean my space while I'm working. Just because I've destroyed so many electronics over the years by not paying attention. All right, so I guess that's fine there. You can see that, right? Okay, so I think the easiest way, let me just make sure. Yeah. If I turn it off and on, it works. All right, we're just fucking going for it. So what I'm gonna do is, why is there a micro USB cable right here? Okay, so we can power off the DC load. Yeah, that's interesting. The output is now going all over the place because there's no load. All right, so I'm gonna grab the Ethernet cable so we can see if we can end up logging in. And which are the two pins? What's the 5-volt pin? We're over here now. Put on P9, so it's ground I'm already using. So let me go, where did my jumpers go? Right here. All right, this is a little scary. All right, so ground we can put over here. And then fuck it, bros. Output right here. She need a longer one. So it is, there's one space. Nothing is happening. Something should be happening, but it's not happening. Is it this ground is not right? Okay, I just didn't plug it in. Oh no, I did. Interesting. So interesting. So I'm powering through the pins. Is it? So I guess I've never tried powering it through the pins, but it's not working. Can I find an article about this? I thought we looked at this. Some guy had done this. We looked at this during one of the streams. Huh. So let's try doing it through the, so it's D ground. That's what I'm doing. VDD 5 volts is pin 5 on P9. Let's just try to hack it with the plug. Okay, so I guess what we could try a few things, but I guess what I'm most curious is if it powers up from the barrel jack. So we're going to try that. We're going to take crop clips, crocodile connectors. Crop clips is in mended mark. Right, that's really good. Okay, so it's not turning on. One connected with. Alright, so now what I'll try is the DC power supply. Maybe it's because the voltage is too low. So that's turning on. This is actually pretty loose over here. Okay. The DC plug over there was pretty loose. Now there's no load and it's super stable. Yeah, that DC fucking... Ugh, that ground was loose. Hey, okay, right away. Loose ground. There's the loose ground the whole time. Okay, so we're now powering the BeagleBone via the DC to DC converter. Whoa, it's freaking out. Okay, it powered off. Looks like it might have overheated pretty quickly. Uh-oh, now no BeagleBone light. Okay, so that's still working. Oh. Might have fried the BeagleBone, motherfucker. There we go. Nope, it's not fried. Whew. I'm going to have a dedicated 12-volt supply here. That is going to be this guy. Actually, no, not. Okay. I just think these wires might be too small to supply the BeagleBone with the right amount of current. So I think I have a couple bigger ones. 1 and 2. Nope. Yes. Nice. So I got bigger wires. So we're going to try those. Actually don't have better wires, which is hilarious. I guess we can go these two together. We go ground here, ground there, and power on. Nothing. Oh, you know what? Those two are shorted together. Look at the schematic again. Are we sure that the grounds are connected inside this board? How sure am I of that? Alright, I gotta redo this whole fucking circuit. This thing is a mess. I'm wasting my time here. We're going to unplug this. Alright, so yeah, this is crazy town. Okay. We're gonna do Yo, Omu, thank you for the follow, brother. Thank you for the follow, brother. Or sister, or whoever. Alright, this breadboard is truly a mess. I'm already fucking it up. Alright, so we're gonna do this top rail is gonna be the input voltage. Input voltage. And then that's also shorted with enable. This is the top rail is our 12 volt heavy hitter. Our 12 volt rail. Now we are going to we're going to ignore power good. PWM we are getting from the signal generator. It's right there. Ground. We're gonna hook up all the ground pins as well. We got 2 over here. Ground and ground. Okay. We have 2 grounds down here as well. I just ruined this jumper for that. Ground and another ground. You know what? We are going to move everything up 1 slot so I can make sure to get a huge connector in that output pin. So these are both voltage in. ground, and ground like we just had. PWM, we are going to move the PWM input. We are being relocated to over here because it doesn't matter because you're very low voltage. Okay. Output is going to be this big, thick wire. Wait, let's wire up another ground. This is gonna go over here. We're going to do across the board wires for more grounding there. Do I have another wire of a similar length? No, I do not. I'm gonna go get one. Got another one. All right. It is taking a little bit longer to get this done than I thought it would. But this is important because then we can just get back into circuit design. All right, so we got the two grounds there. So this output, first we're gonna do the DC load again, honestly. All right, this should be it. So we got this is the frequency, the signal generator, goddamn. Let's power this thing on. So we got the signal generator, channel 1. So we got to get our probes back set up. This is numero uno. And it looks insane. Why does it look insane? Because there's no common ground. That's why it looks insane. Okay, I was wrong. Okay, this is not hooked up. Ground is gonna go here. Still looks insane. Oh, that's just the PW, that's the raw signal generator input. That's not what we care about. What we care about is that test point. The test point, which is the input to the DC to DC converter. Nice. That is a steady situation. Okay. Now, let's look at the output. So that's the blue guy. All right, in order to probe this, I'm actually going to snake a little wire under here. Put the board back. So now the output's on this little brown wire. It's off right now, which makes a lot of sense because system's all off. Positive wires here. Okay, so let's look at that output. Okay, output's still doing the weird loading behavior. So this is what I was doing with the BeagleBone. So let me get the DC load in here. If I go here with this, I go here with this. So this is the output on this 2 right here. I turn this on. Current mode, 1 amp, rock solid. I think it just wasn't getting connected before, which is pretty confusing. All right, so how are we gonna wire up the BeagleBone to make a better connection? I have my custom wires box. Which I think is just gonna bring disappointment. Okay, wait, this might work. We got terminal BeagleBone deal. We could try this first. So unplugging the load. We're going to positive here, negative there, and we're going to go for it. Nothing. And it looks like it's all wired up. Okay, what if I do current mode 0.2 and I plug it in at the same time? And I plug in the DC load at the same time. Oh, that was the wrong side. Have I ruined everything? Okay, so now the load is plugged in at the same time. As the BeagleBone is plugged in. Okay. Let me turn the load off. Current 0 amps. And then it freaks out and crashes. Okay, so I think what's happening here is that I know what's happening here. Current 0.5. Now it's going to turn on, I bet. There's not enough load all the time. Is what's happening. So So that's really interesting. So with the way this circuit is designed, when BeagleBone's blinking, by the way. So if I turn the, so I have the DC load in parallel with the BeagleBone. If I turn this off, the output goes wonky and it powers off. So there's got to be some input protection that's going on here. So if I do current 0.25, current 0.5, there's got to be some input protection here. Makes a lot of sense. It really wants to have a stable input voltage to turn on. I mean, for what it's worth, it's drawing 100 milliamps. So it's drawing nothing. Yep, and there it goes, turns itself off. Because the output's unstable. Oh, there we go. So if we just power it directly there, and then have a ground wire that is not enough ground. Is it the lack of current that it's able to pull that it decides to turn off? I think it just might have been our shitty wiring, maybe. Okay, and now it's off again. Okay, well, I think I've sat and I've looked at this for long enough. Thank you to the people that sat and looked at it with me. So it looks like this DC to DC can work. Let's see if I can talk to it. $100 milliamps out of the power supply. Oh, there it goes. Okay. Yeah. I think... I'm gonna take it step. This is what it doesn't like. This. The BeagleBone doesn't necessarily draw enough power to use this part, I don't think, which is really interesting. What the fuck is that, bro? Maybe it's my circuit? Okay. So is there something up? I'm gonna take it step. I can feel the ground beneath me moving. By step, it feels like there's something in the air. I think I found a reason to stay, and then it faded away, and I'm already on my way out. I found a reason to stay, and then it faded away, and I'm already on my way out. I found a reason to stay. I'm gonna take it step by step by step by step. I'm gonna take it step by step by step by step. I'm gonna take it step by step by step by step. I'm gonna take it step. So I think it's just, it might be my design. Ugh. It might be that PCB. I really didn't lay it out with a ton of care. Yeah, I think it might be my layout of that board. What is it supposed to look like? Yeah, this shit is basically fucked. Hmm. Yeah. Power out. Open drain power good output with internal pull up resistor that is pulled to ground when the output voltage is out of its regulations or during soft start. Let's go look at PG again.
makes it feel good. Ain't no fighting, no destroying. It's the music that moves your heart.
Hours outside of regulation limits or during soft startup. Out of regulation limits.
Drifting off to search for something new. I don't know if I'll be coming soon. I'll be sailing. You've been waiting. Feeling lonely. Don't erase me. Please don't always focus on my flaws. Or always say what I've been doing wrong. The sea's changing. I've been tired of waiting. You keep drifting when no one's listening. Mathematic waiting.
I don't get it, bro.
Cinematic erase me. Problematic hold you. Too much static inside me. Elevation deny me. Cinematic clear, babe. Elevation. Used to walk around so terrified. Now I feel like I am more alive. Deep inside me. Don't deny me. Keep it clear, babe. Call me highly. I can feel these reasons ain't enough.
I think my layout might be bad.
Giving up. Keep 'em looping. Like the echoes.
It's happy, so it's 100 millivolts right now.
We wanna let
140, 130. Maybe when it finishes booting, it's like, okay, I'm gonna draw less power now, and then it's gonna turn off. Yeah. I wasn't watching it. Fuck.
mathematic waiting.
Let it turn. Alright. 140, 130, 150, 140, 150, 140, 120, 140, 140, 138, 137. Yeah, it's showing at the same power usage. 140, 52, 41, 64, 19, 120, 113. Yeah, and then it drops. I'm gonna use a different regulator. I think I have to figure out, because I have to understand this board. I'm gonna get some hot water. I'll BRB, dude. Intermission times. I'm not going to use this DC to DC converter. It's really not worth the headache. I think this design that I was just using has problems that I have not run into in my other use of the board. But I think there's issues with issues around low current situations that I just haven't run into before. So I think it's time to look for a 5-volt regulator. It's time to go shopping. What is the Spark Fun? Yeah, L's. Yeah. Yeah. What is that footprint that I've been using? SO SOT 223. Whoa. Alright, so we're just shopping for a regulator. We have that DigiKey one. We want to do anything above an amp. So I'm basically just looking for what is the cheaper 25 cents. Diodes Incorporated. This guy looks pretty good. Let's look at this one. this kind of is warm. Thermal resistance junction ambient. 120 degrees per watt. Alright, so that's just way too fucking high. So I don't think this package is gonna work. Yeah, 220, 50 degrees per watt. Why is it not giving me... power dissipation? Alright, I'm off of this manufacturer. Yeah, bro. Input voltage max is 12. We don't want that. We want like 14 and up. Hmm. It's not gonna give me the power dissipation shit. Let's try this diodes incorporated one. Data sheet. I'm like in the find window, but it's not. Okay, this is kind of what you want. Thermal resistance, junction to case. Two, 5, 2, 3. Yeah. Okay, so this is 10 degrees per watt. Okay, this is our part. AZ 117. $67 a piece. Okay. Okay, so let's draw this into the circuit. Chat, what's the fuck is going on, dude? All right. So, the typical application circuit. AZ117. Let's just see if that is in KiCAD. Place, add symbol. It's fucking in KiCAD. Wait, this is not quite it. This is not quite it. Okay. We're fucking out of the mud, dude. Give me the gong. Give me the gong. Uh-oh, where's the gong? I've lost the gong. We're out of the mud with it, dude. Golly. Stop the freaking gong. So we're gonna use linear voltage regulator, that buck converter. Sadly, lives for another day. Which is fine. I do use that circuit as a fan controller in other projects, or have used it in the past. This is already wrong. This is already wrong, blah. So we need a cap there. So at some point I'm gonna have to go figure out what the hell was up with that. design. I think it was just the copper polygons. I think it was just the layout. Which happens. I haven't really used it at that low of current draw before. Actually, never have. And I've definitely never used it at that low. Normally, it's like a high power thing. And I've never used it there, and I've definitely never paid attention to it at that low voltages. That low of voltages. So, all right, typical application circuit.
Before daybreak there was nine, and as it broke there was one. From moon to sun it goes on and on. The winter battle was won, the summer children were born, and so the story goes on and on. Come woman in your left piece, those sweet bed with the huskies, soaked in feather where the fields are green from here to
Is this the same? Someday the grapes will be wine, and someday you will be mine, and so the story goes on and on. Come woman in your left piece, those sweet bed with the huskies, soaked in feather where the fields are green from here to eternity. Come woman in your own time, far, far, far from the virgin vine, rise up now from the dead leaves, come back to me. Theory circuit. Man, that's a mess. Nice. Okay, so it's a... Okay, that makes sense. So it's a 10... This is the same two caps. 10 microfarad, 22 microfarad. That makes sense. Need two more. So we can use low ESR caps.
That which was put in the
Anything else about these caps? Where is C3? Okay, it's right there. Cool. So it updated, automatically updated that. Okay, so we want. So this is NUF. And then this is 2 UF. Okay. So Mm. Okay. So let's pick some caps, which is kind of a waste of time. But it's okay. UF. Sorry. So I'll make them both 25 volts and up. And select low ESR. Twelve, 10. These are pretty big. So that's what I thought. So we want relatively, we're going to use relatively large caps here. So footprint is yep. We're going to use the same thing for this input one as well. All right. All right, so now we can open the circuit back up. Update PCB. Boom. Why did that not? That's interesting. So it's, I think C4. Cannot add C4. Ah. I just copied and pasted this wrong. Center, center. What the fuck are you talking about? Alright, bring this in. No, no DRC. Alright. Okay. Jesus Christmas. Okay, and I think I gotta add a fuse, dudes. Adding a fuse is extremely annoying. But now this doesn't have all the fun features that the DC to DC had. So I think we gotta do a fuse. Are we just laying out now? Should I do a fuse? It's gonna be annoying. I literally never use fuses and stuff. Is this a learning opportunity to understand the magic of fuses? Am I depriving myself the opportunity to learn about fuses? I could put it on the back. How much clearance would I have back there? Kind of a lot, but then I could never really get to it. Ooh, we could do a blade fuse. Ooh, let's think about that. Like a automotive blade fuse.
One more time.
Fuse.
One more time.
Fuse holder blade.
One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing.
Eh,
We're gonna celebrate.
I'm looking at these.
Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah, alright. Don't stop the dancing. One more time. We're gonna celebrate. Oh yeah. One more time.
Fuse holder blade ATO. Let's Google that.
One more time. We're gonna celebrate. Oh yeah.
This is what I'm thinking.
One more time. We're gonna celebrate.
Is there the mating product?
One more time. I'm just feeling celebration tonight. Celebrate. Don't wait too late. No, we don't stop. You can't stop. We're gonna celebrate. One more time. One more time. One more time. A celebration. You know we're gonna do it right tonight. Hey, just feeling. Music's got me feeling the need.
Is there anything right angle?
Come on. All right, we're gonna celebrate one more time. Celebrate. celebrate and dance so free. Music's got me feeling so free. Celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got me feeling so free. We're gonna celebrate, celebrate and dance so free. One more time. Music's got
So these clips, I'm having a hard time. These are the clip mini blade. It's not gonna work. Shooter. Horizontal. Shock safe fuse holder. See, I kind of fuck with this. This is kind of beast. Let's try this. So this would be like a right angle update from PCB. Yes. So now it's on the other side of the board. They're telling me there's a 3D model, bro. Ooh. Okay, that's kind of good. I think I have to do it. I'm too spooked about it to not. I'm on the wrong screen. So this is what this looks like. View, 3D viewer. So this is what, with the fuse holder, this is what it looks like. So that means I can get at it with the board installed. I kind of snake my little fingies in there. I think I'm gonna try to make it work. This shit's fucking stashed in there now, bro. Mm-hmm. I think I'm going to move these transistors all up a bit. Actually, maybe not that one. Actually, maybe just that one. Just give myself a little more room to work with this. There's not a clearance that I'm really working against on this side. It's just kind of a convenience thing. So I think I'm going to hang that off. As much as I can. Like that much. Yeah. into views. I guess that already is. Hmm. Ah, so I fucked up. So this is over here. That's what the difference is. Hmm. God damn. Rack door just opened, scared the shit out of me. Alright, so the flow, it didn't make a lot of sense now. So let's oh, I just hit H. What did I just do? I turned on help. Help! So then 5 volts really begins right there. Okay. So, cheap viewers, sliced imperialism. What's up, dude? You ain't gotta be bringing that advertisements in here. All right, so can I rotate this? Hmm. I'm doing the bad thing. Oh, I went the wrong way. Now it clears both. I think it's actually kind of hard to see what the maybe if it would look better if you did this. I guess none of the other labels are rotated. I'm just like looking at this in 3D and I'm not totally stoked with the look. Guess it really doesn't matter all that much.
What's going on? Could this be my understanding? It's not your fault.
I was being too dumb.
I must admit, it's my pride that made me distant. All because I hope that you'd be someone different. There's not much I know about you. Always make you blind. But the answer is in clear view.
Kind of unstable with it.
You'll find face to face. I turned away 'cause I thought you were the problem. Tried to forget until I hit the bottom. But when I faced you in my blank confusion, I realized you weren't wrong. It was a mere illusion.
I am going to switch up the labels with this.
Just to leave this unresolved. It's not hard to go the distance when you finally get involved face to face.
How does that look? It looks a little bit better.
It really didn't make sense just to leave this unresolved. It's not hard to go the
I'm gonna grab one of these connectors.
when you finally get involved face to face.
I have 3 of these.
It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feeling's in my bones. It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feeling's in my bones. Can you feel it? Can you feel
Yeah, we're gonna do this.
it? Can you feel it? Can you feel it? Yeah. 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 At last, the long wait is over. The weight is off my shoulders. I'm taking all control, yeah. My mind is set so free. I'm where I want to be to get the best of me. Can you feel it? Can you feel it? Can you feel it? Can you feel it? I see you feel the way I do. The feeling so true. The good feelings coming through. My mind is set so free. I'm where I want to be to get the best of me. Can you feel it? Can you feel it? Can you feel it? Can you feel it?
All right. So
It's been much too long. I feel it coming on. The feeling's getting strong.
we can move this down a little bit. And it'll be easier to see.
The feeling's in my bones. It's been much too long. I feel it coming on. The feeling's getting strong. It's been much too long. I feel it coming on. The feeling's in my bones. Can you feel it? Can you feel it? Can you feel it?
Mm.
Can you feel it? At last, the long wait is over. The weight is off my shoulders. I'm taking all control, yeah. My mind is set so free. I'm where I want to be to get the best of me. Can you feel it? 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 Can you feel it?
Boom. Okay. Does that actually look better if I align them? No, it doesn't look better. I'm self-conscious about the way these two parts look. It's 9 p.m. Really should get to actually routing this thing. I might have to say fuck it here. This shit's taking too long. All right. Pencils down, bitch. Pencils down. I'm really happy with this. I'm gonna quickly... Let's actually go look at one of these fuses on DigiKey. Yeah, this is the guy. $6? Fuck me. 0031 355 3551. Yep. I don't have any of the part numbers in here. Digi key PN. All right, so we got the fuse. So let's bring close this, discard changes. Let's bring this into SolidWorks again. Just to do somewhat of a final fit check here. So, file, what was it? I think it was in the PCB editor. Export step. Alright, so now I gotta open this. I have to open this in SolidWorks. But first, I have to find the file. Okay, now I've got it copied over here. I'm doing stuff. Project. Super rag. That's not really V2. I guess it's like 02. Okay, now it's opening. Sorry about the delay. So this is one of the greatest parts about fuse holder has errors. So helpful that KiCAD knows what a step file is. So helpful. Okay, so now we can open this. Not this. Where are you? You are in fan module. We can do BBB and cape. And what we're gonna do is hide this. Insert component, open rack event V2. We are going to how did I do this before? Let me go like this. So you, mate. You and you. You and you. Now they're on top of each other, which looks crazy. But then we can just hide this first one. Ta-da! Man, this is really sick. This is quite cool. Yeah, so will I be able to get at the fuse holder? This has problems. What is the command? Import. Import diagnostics. Attempt to heal all. Boom. Okay, so where is that big model? Why is the rack not showing up? There it is. That's what I'm looking for. Yeah, so you're kind of going to be able to get at it. So where's the 5U? Actually, I never did this back piece. Insert component pattern. Mirror components. Then we're going to mirror around that plane we just made. That's wrong. Yeah. Opposite hand version. Uh-oh, computer's farting. Chat, what it do? What it do? Holy crap, could not be replicated big time. Okay, so that's a fucking mess. If you do it that, if you do mirror component, that is pretty hacky. Okay, whatever. Okay, here we go. At long last, you can still get at it. You can still get at the fuse, you can still get at the USB port, you can still get at the Ethernet jack. Okay, so
Man, I'm gutted. There's no atmosphere.
it's that time of night, dudes. This is the best song on the playlist.
No one's dancing.
You can still get at
I've given up hope on this place.
the fuse. Kind of weird. What part is this? That's the AI box.
I, Zeus, the greatest god of all times, declare that ye have offensed our sacred community. Your punishment shall be an example for all mankind. And do not expect any mercy from me. You've betrayed the faith of your lords, poor mortal humans. You are sentenced to spend your entire life in a never-ending dance on this floor. And now, for eternity, you shall enter the mighty wrath of Zeus.
I might actually switch the position of the LED. You're gonna be able to tell, it's fine. I'm not gonna do that. Okay. I think we say bucket and start laying this thing out.
Eternal dance, the ultimate punishment for those who dare defy our strength. Suffering, moving, spinning round and round. No more sleep for the unfaithful.
I'm getting absolutely fucking
Done. Now
hammered.
and don't even think to escape, for your salvation might be on the floor. Wake the dancer in you. Dance, dance, dance.
All right.
And now, the eternal dance.
I'm happy with mechanically how that all works, but I need some tea. I'll be RB. Yeah, bros. Sorry for the absence. Man needs his tea. Oh, you got this song though. Let's lay out this PCB. All right. First, we gotta do the DRC over here. ERC. Oh, you have to do that fucking pin shit. I hate this dumbass. What is it called? Power flag. Stupid. the different voltage potentials in the project need to have power flags. I think. These are in the wrong order. Well, V bus. Wait, where's 5 volts? Now we got flags and everything. Bang. Alright, so now I've labeled all those stupid power flags. Because KiCAD needs you to do that. Looks like a fucking... Looks like something in a video game, honestly. Okay. Got the DRC run. It is time to draw. So I was using these predefined sizes. No, net classes. Output power minor. Output power and power. So, okay, so we can either label how we want the tracks to be in, basically in the schematic or in the layout. I am not really sure. Obviously you can do either, so there's gonna be stylistic decisions to be made here. Part of me is like, okay, all the 12-volt stuff should probably let's do this. Let's do the low voltage stuff first. Let's do the stuff that doesn't matter as much first, I think. I've also kind of been in terms of like thinking about the design. Come on. There we go. The routing of the low voltage stuff is kind of the most annoying. just in terms of like me thinking about this. Because you have these two big ass BeagleBone connectors that you can't really do anything about. Yeah, like look how long this one is. I mean, it's doable. I mean, they designed it so people can like build stuff around it. It's definitely possible. It's just a little bit less than ideal, which is fine. Like these three, like the source, right, of these MOSFETs should probably be a pretty big conductor. Should probably be a lot of copper. All right, let's just keep working through this stuff. So I'm just clearing out the pieces that we did before. This one wants to go on that side of the 1.8, so we can take the 1.8, bang it like that, bang it like that. These are really small signals that are being driven by the 1.8. They're literally like thermistors. It's almost nothing. LED 1 is gonna get ah crap. on the pins, it might make sense to swap two and one to clean things up. So let me do that. So that's a little bit cleaner there. Mm-hmm. Yeah, we definitely are gonna use a via for that. I think a lot of the weirdo stuff we're gonna use vias for, or at least do underneath the board. That's power, that's power. Any like major this stuff over here. This is definitely that power minor. Where did I do that? Where was that? Output power minor. For sure. I'm gonna do all of the 1.8 volt stuff. Okay, we can do output power minor. Nice. So, pull up. We also want this to be kind of big. Which is getting kind of annoying. The fact that these little things are everywhere. I would say they're cluttering my otherwise pretty clean schematic. I guess it does show reader like, hey, this is a little bit thicker. Honestly, don't love it. First time using them. We can open the layout back up. Starting to look good in here. Man, this song rips, dude. So nice. Okay. So we're gonna do vias. This is gonna be bang. So I'm gonna place a via next to each of the 3.3 volt pads. And then do it up here, but we're gonna actually do the routing on the back. So where art thou? 3.3 volt. Ooh, fuck, it's over there. Damn. Maybe it makes more sense to go like this. To do fresh fish sandwich. Fresh fish motherfucking sandwich. I love you so much.
Show me your moves.
Oh, Alright, so if we drop the 3.3 bang like that. Ooh. Ooh, what? Did I miss this one? I did. Uh-oh, how did I do this before? Chat, are we cooked? I'm cooked. Did I do this? Ugh, I think I did this. Puke. Was that the only way? Could we get a replay? I would be very hard to do. I think I could. Like NFL instrument. Dude, I need NFL. Okay, we're taking a fucking 10-minute break. I need to add NFL sound effect to the stream. Like right now. We're doing it right now. Where is... Sound buttons world. We need NFL. NFL boosted. Nothing? NFL. Yes. Yeah. That's the one. That's exactly. That's only for special occasions, dude. NFL mentioned. That's only for extremely special occasions. Where do I keep the files on my computer? Soundboard. Bang, dude. Alright, it's in the board. It's in the board.
Show me your moves.
£1 is gonna love that. That's a funny thing to have in the soundboard. Alright, lock him back in, lock him back in, lock him back in. So how did I do this? I think I might have literally, I think I went around, which is unsatisfactory, to say the least. It's actually not that bad. So, but we should switch. 0 and 5 on the pins. Because that'll just make it a little bit cleaner. I think I've gone back and forth with these two already a few times. But who's keeping track? Not me. Alright, so now we update PCB from schematic, and then those two pins are going to be swapped. So now 0, we can snake it like this. And then 5 has to also travel a long way. But now that's pretty clean. I think, yeah, that's definitely how I did it last time. That's not that bad. Oh yeah, we should do it. We should do the back like this because... Alright, and we should... The 12 volts here are all additionally out power minor. I have now kind of grown to dislike these specific net labels like this. But I don't really want to clean that up now, so I'm not going to. All right. Nice. Yeah, that's probably how I'm gonna do these vias here as well. What did I do? This is fine. Oh, this moves right here. No, 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 no. The fuck you doing, bro? Hmm. Guess we want to also have this be really big. Yeah, so that means we gotta do it over and over again. No, I want output power. Huh. Oh. No. Shouldn't this be huge? Hmm. Why is that not huge? Yeah, I think we're gonna have to rethink some of the net class stuff, unfortunately. That's okay. Mm-hmm. group items, and then we're gonna center this horizontal center. Go like this. And then under here, that'll work. Hmm. All right, this might take us out. This might be the last track of the night. I'll end it on a fucking classico. Okay, so interesting. Phew! Less. Actually, we don't even need to... Interesting. All right. I have a feeling I'm not going to get away with this. Yeah, definitely not. Because we're going to have to do the ground pins. So we're probably going to do this like this. This is just to save my work, but I'm gonna do... Just so I don't forget the idea. All right, chat. All right, chat. Thank you for watching. That's it for me tonight. That is it for me tonight. 5 hours, 40 seconds on the time. All right, we're getting close here. I think next time we'll finish the layout and go find the components and then order boards. Yeah, that's it. Okay, everybody. Thank you for watching. Goodbye.